Okay, what we're doing is we're looking at combined transformations today. So we have a function can have any combination of different types of transformations acting on it. So the first transformation that we looked at for the curve y equals fx is if it translates the function vertically. So y equals fx plus c, it goes up if c is greater than 0, it goes down if c is less than 0. We then looked at horizontal translation. So y equals f of x plus b translates the function horizontally. So it moves them to the left if b is greater than 0 and to the right if b is less than 0. We then have our dilation. So we have that y equals k of f of x dilates the function vertically with a scale factor of k. It stretches if k is greater than 1. It compresses if 0 is less than k is less than 1. And it reflects the function in the x-axis if k is minus 1. And our last one, which we looked at last lesson, is our horizontal dilation. So if we have y equals f of a of x, it dilates the function horizontally with our scale factor of 1 on a. We have it compresses if a is greater than 1. It stretches if 0 is less than a is less than 1. And it reflects the function in the y-axis if a is minus 1. So we are going to be applying multiple transformations and combining them. So we need to consider the correct order that we use in which the transformations are applied will affect the final function and graph. So we have to do it in the correct order. So when we're doing translation, so when we have vertical translations and horizontal translations, the order is not important. So what that means is, for our little example here, we want to find the equation of the transformed function. If y equals x squared is shifted up 3 units and to the left 1 unit. So what that means is, if we have y equals x squared, what do we want to do first? Horizontal or vertical? Vertical, okay. So we're going to vertically translate. So we're going to do an arrow and we're going to write VT for vertically translate up 3 units. What that means, if we're vertically translating something, we're getting y equals x squared plus 3. So we're adding the 3 to the end. Once we've done our vertical translation, we can then do our horizontal translation. So our horizontal translation, which is left by 1. So if we're moving it left by 1, what we do is we do y equals, in brackets, x plus 1 if we're moving to the left, all squared plus 3. Now what we're going to do is we're going to see why the order isn't important, because we're now going to do y equals x squared, but we're going to do our horizontal translation first. So we're going to go horizontal translation, left by 1. So if we do horizontal translation first, we get y equals x plus 1 all squared. And then if we do our vertical translation up 3, we get y equals x plus 1 all squared plus 3. So it doesn't matter. The order is not important. Next we have dilations only. So dilations only, we have that order is not important. So we want to find the equation this time of the transformed function if y equals x cubed minus 1 is dilated vertically by a scale factor of 5 and dilated horizontally by a scale factor of 1/2. So again, we're going to do it both ways. We're going to start off with our y equals our x cubed minus 1. And we have let's do our horizontal dilation first. So we're going to do our horizontal dilation. We have our scale factor equals 1/2. So that means that A is equal to 2. So when we do a horizontal dilation, we put a 2 in front of our X value. So it's going to be Y equals 2 lots of X all cubed minus 1. Okay, then if we do our vertical dilation, what we will do is our vertical dilation is that we have our scale factor is K, which equals 5. So we'll get Y equals, and our 5 will go out the front of our entire function. All right. Now if we do vertical dilation first, so we still start with Y equals X cubed minus 1. We don't need the bracket, sorry. We will have that our vertical dilation, we have that K equals 5. So we'll get Y equals 5 lots of X cubed minus 1. And then our horizontal dilation, we again have our scale factor equals 1/2, so therefore A equals 2. So we'll get Y equals 5, and then remember our A only attacks our X, so it's 5 lots of 2 lots of X all cubed minus 1. Sorry, I'm so distracted by them outside, I'm struggling. So, it's not their fault that their teacher hasn't shown up. All right, so pretty much all you need to know from this is it doesn't matter. Pretty much all this is showing is it doesn't matter whether you do horizontal or vertical if you have both translations or both dilations. Now, if you have horizontal translation and vertical dilation, or vertical translation and horizontal dilation, so you have one vertical, one horizontal, the order is still not important. Okay, so what we're going to do is we're going to find the equation of the transform function if Y equals e to the x is dilated vertically by a scale factor of 3 and translated horizontally 2 units to the right. So we have our Y equals e to the x. What do we want to do first? Our dilation or our translation? Translation? Okay, so we have our horizontal translation is 2 units right. So it will be Y equals e to the power of x. So to our little power of x, we're going to minus 2 if we're going to the right. And then we have our vertical dilation. And we have that k equals 3. So it will be Y equals 3e to the x minus 2. All right, do it with dilation first and then translation second to show that it's the same for me, please. All right. Have we done that ourselves? So you should have had Y equals e to the x. We do our vertical dilation first. What we have is that k equals 3. So we get Y equals 3e to the x. And then we do our horizontal translation 2 units right. So we get Y equals 3e to the x minus 2 because we just minus 2 off it. Now, copy that down and then turn the page for me. Boys. Yeah, that's ridiculous. How old are we down on the next page? Okay. Yes, this is thick. We got a lot to get through. No. Okay, so what we have now is if we have a vertical translation and a vertical dilation, or a horizontal translation and a horizontal dilation, we have that order is important. So if you have two horizontal or two verticals, order is important. So let's investigate that together. So what we have is we want to find the equation of the transformed function if y equals x squared is vertically dilated by a scale factor of 4 and vertically translated by 3. So what we have is y equals x squared. What we are doing is let's do our dilation first, just because it's first in our question. So we're going to vertically dilate and we'll get k equals 4. So when we dilate something, we put it out the front. So we'll do y equals 4x squared. And then if we vertically translate it, we go up by 3. So we'll write y equals 4x squared plus 3. Okay. Now, if we do it the other way, so if we do our translation first, so if we do our vertical translation of up 3, what we get is y equals x squared plus 3. Now, after we do each transformation, that's our new function that we're doing things to. So now, if we dilate this, what we will have, so if we now do our vertical dilation, okay, we have that k equals 4. What we now have to do is, this is our entire function. So we have to multiply 4 lots of x squared plus 3. Now, that is equal to 4x squared plus 12. And see how they're not the same? Yeah, so that's why our order is important. So the order that is important is that we do our dilations before our translations. So the order that we did it first is the correct way. D comes before T in the alphabet, so that's how you can remember. Now, it doesn't matter whether you do horizontal first or vertical first, as long as you do your dilations first and your translation second. And you can just do horizontal dilation, horizontal translation, vertical dilation, vertical translation. But you must, if you have two verticals, you must do dilation first. If you have two horizontals, you must do horizontal first. Yes, Noah?
If I have two verticals and a dilation,
no.
Two verticals,
yeah,
and also like a horizontal.
Yes. You can pick between if you do vertical or horizontal first, yep. But you must, if for the two verticals, you must dilate before you translate. Does that make sense? D before T. It will make more sense as we go through. So, we have this fun, fancy equation for our transformed functions. So when we combine everything together, we want to remember this formula, okay? It's going to be really important for us. So what we have is we have our A, our B, B is pink, our B, our C, and our K. Okay, they're all constants of our transformation of y equals f of x. So we have that y equals k. F just stands for our function. So any function that we're dealing with, lots of our a of our x plus our b plus our c. Now that's where our horizontal dilation is a scale factor of 1 on a, our horizontal translation of b, our vertical dilation of k, and our vertical translation of C. So the order of transformations is important as long as you do dilation before translation. That's all that means. So we can notice that the horizontal dilation and translation parameters A and B, they're inside the brackets. So they change our X values. Then our vertical dilation and translation parameters or variables, K and C, they're outside our brackets and they change the Y values. So the way we remember this is we think of our A and our B and our K and our C as dogs, because you all know I love my dogs. So what we have is AB is Abby, and Abby is an inside dog. Abby is long, so think sausage dog vibes, all right? And Abby is naughty. Abby doesn't do what we expect, okay? Because our horizontals, they don't do what they expect, and Abby needs to wear a collar, okay, because she's naughty. So that means she has brackets around her. Whereas Casey is an outside dog, and Casey is tall because it affects the vertical, and Casey follows the instructions. So Casey does what it expects to do. Okay, because our K and our C do what they expect to do for that. Okay, so that's a little fun way that we can remember what's going on. How cool. All right, let's look at our next example. Or our first example actually. Blake, stop throwing paper. You've been outed on the video now. All right, so let's look at this. We are going to describe the transformations of y equals x squared in an order and give the transformed function. To give the transformed function y equals 3 lots of 2x minus 6 all squared plus 1. So the first thing we have to do is we have to put the function into y equals kf of a of x plus b plus c form. Okay, so right now we're dealing with y equals 3 lots of 2x minus 6 all squared plus 1. That's not in the form. What do we need to do to make it look like it? The 2, right? We need to factorize out the 2. So we're just going to write a little note. So factorize out the 2. So what that means is we'll have y equals 3 bracket 2 bracket x minus 3 bracket bracket all squared plus 1. Does that make sense? And that's where our f is our x squared function. Okay, do we feel horizontal before vertical? Yeah. H comes before V in the alphabet. I just like the alphabet for things like this. Okay, so what we're going to do first is we're going to tell us what our horizontal transformations have occurred on y equals x squared to get this function. Okay, before that though, I might just highlight what everything is. So our C value is our plus 1. Our K value is our 3, our A value is our 2, and our B value is at negative 3. So the first step that we're going to do to our transformed functions is we'll have that number 1, we have our horizontal dilation, because we got to dilate before we translate, remember? Dilation of, what's our scale factor going to be? Scale factor, 1/2. Good job, whoever said it. Okay, because we have that our scale factor is equal to 1 on A, and our A value was equal to 2. So what that means is we started off with y equals x squared. We are transforming it to get y equals 2x all squared. Okay, so that's step 1. We've done step 1. Step 2. So once we do horizontal, we do the other horizontal. So we are now going to horizontal translation. Oh my God, I can't, oh no, I'm spelling correctly. Translation of 3 units because we have that it is B is minus 3. So if we have a minus 3 there, are we going to the left or the right? We're going to the right. There's 3 units right. So that means, so we go to our function and it's now going to be y equals bracket 2 bracket. We just attack the x with a minus 3 in brackets there. Okay, so that's what's happening. Okay, now that we've done both our horizontals, we're going to move on to our verticals. We do translation first, right? No. We do our dilation first. I said, do we do translation first? I was trying to trick you, Lara. So we want to do our vertical dilation. So our vertical dilation has a scale factor of what? Scale factor equals 3. Might do a little equal sign in there. So that means what we have is a 3 at the front of our whole function. Okay, and then our last one is our vertical translation. And we're doing 1 unit up because we have a plus 1. Because we have y equals 3, lots of 2, lots of x minus 3, all squared plus 1. And that's our function, right? In that form. Okay, not in the original one, but in that form. No, you have to remember that equation. I know. But we're going to use it a lot. And we're in our next topic of trig, we need it as well. So don't worry. So we'll be using it as well. Is that? Yes. Okay, move on to the next page when you're ready.
Another page.
There is another 2 pages, I think.
2 pages.
Is there?
There's 1.
1. Just one more? I don't know. Just 1? Okay. But 3 examples?
Yes.
Yeah. Oh, 3 is vertical dilation. So vertical dilation is green and our vertical translation is yellow. All right. So example 2, we're going to find the equation of the transformed function. If y equals f of x undergoes a vertical dilation with factor 5, a horizontal dilation with factor minus 1, and a translation 4 units to the right and 9 units down. So let's just pick apart what we have. So we have a vertical dilation with factor 5, a horizontal dilation with factor minus 1. So that means that it's reflecting in the y-axis technically. We have a translation 4 units to the right and we have 9 units down. So we are going to start off with that equation. Y equals kf of a of x plus b plus c. Okay, just so that we get used to it every time. So what are we going to do first? Let's stick with the horizontal first theme. I think it's just easy if we do it that way. So the first thing we're going to do is our horizontal dilation. So horizontal dilation, we have our scale factor. Let's shorten it and just do SF equals -1. So because we have our scale factor is -1, what's our A going to equal? So remember, scale factor for horizontal dilation is scale factor equals 1 on A. So A will be -1. All right, so we start off with y equals f of x. What we have, it's going to be y equals f of -x. So far? Okay, step 2. We have our horizontal translation. So our horizontal translation, we have 4 units right. So if we have 4 units right, what is my B value going to be? It's going to be a -4 because we're moving to the right, we're minusing. So that means my function is now going to be y equals f, lots of negative, lots of x minus 4. Okay. Is everyone following with that? Does everyone get what we've done so far? So far we've done our A value and our B value. We've talked about Abby. Now we're going to talk about Casey. So we have step 3. Why is my pen not working? There we go. We have our vertical dilation. What's our vertical dilation? It has a scale factor of 5. So therefore, K equals 5. Because remember, Casey does what we expect. We're happy with Casey. Casey's a good dog. So y equals 5f, lots of negative, lots of x minus 4. And finally, we have our vertical translation. And its translation 9 units down. So if we're going down 9 units, that means that our C value is going to be minus 9. Oops, that does not look like a 9. Oopsies. So we'll get that y equals 5f, lots of negative x, lots of x. Oh, no, we don't need an x. No, what have I done? So 5f, lots of negative, lots of x minus 4, close your brackets, minus 9. So therefore, the question is asking us to find the equation of the transform function. So therefore, we have y equals 5f, lots of negative, lots of x minus 4 minus 9. What we can do here is expand the brackets within the brackets. So we can write that we have y equals 5f, lots of negative x plus 4 minus 9. Okay, so there are 2 different styles of questions that we have. Do we pause or do we keep going? I say stop.